Good day, all. My name is Kumo, and I am a course advisor with ECT located in our Johannesburg office in South Africa. And I'd like to welcome you to today's webinar. So, in order for us to minimize any sort of interruptions or any distractions, could you kindly just take a look at the screen in front of you and turn off the notifications so we don't have any interruptions. And we also have a Q&A box where you can actually type in your questions as we go, and Steve will be able to answer your questions. We will be offering, no, not offering, but we will give the copy of the slides as well as the recording within 2 business days from today, and it will be sent to your email. So if you could kindly monitor your emails, and if it's not in your inbox, please check your junk and spam mail. And then the certificate of attendance, there will be a link given and a QR code at the end of the webinar. That's where you will be able to take a screenshot or follow the link, and there'll be a short survey for you to complete. Please do that so you are able to receive your certificate of attendance. So I just want to go through what ECT is all about. And ECT is an engineering specialist, which is well affiliated with the Engineering Institute of Technology. So our programs are industry-driven programs, which are designed by industry experts. So that makes it possible for us to offer world-class accredited education. And that's all thanks to our lecturers and instructors for our courses. This is made possible by our unique delivery model. I think you guys might have missed me there. There was a bit of a situation with my internet here. So as I was saying that we do offer world-class accredited education, which is made possible by our lecturers and instructors, as well as our unique delivery model. So I just want to go through the conduct that's expected from each and every one of us. So please just keep the discussion lawful and respectful, and so I don't have to kick anyone out. But anyway, I don't think that will happen. It's never happened. So we can get started. Today's presentation is testing, commissioning, and maintenance of electrical equipment. Sorry about that. And it will be presented to you by our managing principal, Steve Mackay, and he will be taking over from now and giving you guys some insight on today's topic. So Steve, if you don't mind, you can take control and you can start with the presentation. Thank you.
Thank you very much, Kuma. I really appreciate it, and really great to be here today. Kuma will tell me if I'm, logged out.
If you guys can hear me, can you please give me a thumbs up?
Just give a thumbs up in the chat box if you can. Chat box. Can you hear me, Kuma? Okay. Yeah, we've got Sam saying yes. King.
Okay, perfect. You can go ahead, Steve, if you can hear me.
I'm going to ask you a lot of questions in this presentation. It's on testing, commissioning, and maintenance of electrical equipment. And hopefully you can hear my voice. If I drop out, Kuma will jump in and say, "Hey, brother, you've got a problem here." So um, now there's 100 slides here. Obviously, it's physically impossible to go through 100 slides in 45 minutes, but they're there for your record. So I won't go through every slide. I'm just going to go through the critical ones, and then obviously the rest is background information. My wife always says, "Mate, why don't you just keep to the slides you're presenting?" And the answer to that is, I love giving you lots of extra information, lots of extra detail, because learning isn't in a little box. It's all spread out, and I learn as much from you as you hopefully will get from this presentation. So there we go. Now, my background is I work for EIT and ECT, Engineering College of Technology, and we're all one big happy family all over the world, happy days. And we've got a very active campus in England, UK, and obviously, which I'm presenting on today, Engineering College of Technology. And we've got many degrees happening there online. And we've also got obviously an office in Perth, Western Australia. So this is me, my background. You've probably heard about me before. And I love engineering education. I've been working as an engineer for many years. And let me just get my little pen here. So I really love studying every day. And obviously, for better or worse, AI is a very good tool today. And obviously, we've got some incredibly hardworking and happy, hardworking instructors, lecturers all over the world, from Barcelona in Spain to London to Johannesburg to Sydney to New York, you name it. Okay, so they're all over the place teaching, and they all have a passion for engineering. And I suppose there's a lot of challenges today in the economy and lots of issues, but at the end of the day, the trick is to keep persisting, learning new things, trying new solutions. Don't ever give up. So this is a bit of an agenda here. Hopefully you can all see the agenda. I'll just circle it here. So we really just want to talk about the objective today, talk about asset management, which is sort of maintenance, insulation condition, and insulation tests. Just want to talk about that, and partial discharge fundamentals, actually checking the quality of your electrical infrastructure, contact resistance, brake operating mechanisms. Some talk a bit about that, and then talk about obviously SF6 condition monitoring, maintenance procedures, oil testing, and then some issues about installations and safety mechanisms. So I'm going to go through a lot of stuff. As I said, I'm not going to go through every slide, but I will go through what I believe are the core things. So really, we just want to really talk about maintenance of electrical equipment, talk about testing, inspection processes, commissioning workflows, um, and just really trying to look at practical outcomes here. So that's where we're coming from. And we've got a happy crew here, 40 people here, and then probably another few hundred that'll get these slides. So if you don't attend today, don't worry, the slides will be sent out to you in due course. So just from a commissioning workflow, we always have this debate between commissioning and installation. Commissioning workflow, here's a high-level look at commissioning for electrical systems. Obviously, pre-commissioning drawings. One of the most frustrating things with drawings and documentation, which I'm going to emphasize throughout this presentation, is electricians and engineers don't always like the documentation, but it's absolutely critical. Nothing's more frustrating than coming onto site and finding all the documentation's out of date. Mate, where's the stuff? It's not here. It's all out of date, all incorrect. You know, the actual documentation always needs to be up to date. So pre-commissioning drawings, lockout, tag-out, inspection, cold checks, insulation resistance, functional checks, things like interlocks, mimics, SCADA panels, protection, secondary injection, logic trip tests, energization plan, that's important, and then obviously the handover, and as left settings, test reports, baseline reports, punch list, closures. Punch list at the end is always a massive pain, as you all know, walking around, opening the switch box and going through it and finding this termination hasn't been done, this hasn't been done properly, or it's missing a tag, going through all that and getting it remedied. Obviously, a lot of frustrating time spent on that. Anyway, so the topic today is obviously testing, commissioning, maintenance of electrical equipment. I just want to, as I say, go through some of the key issues there. And obviously, one of the drivers is asset registers. There's a list of items in asset registers, very important. Again, documentation, doing things the right way. Can anyone tell me here the difference between condition-based monitoring and the other one is reliability centering maintenance? So condition-based maintenance and reliability-centered maintenance. What is the difference? Any suggestions? Just put it in the box. So just type in the box there, text in box. Yeah, I'll just text it in the box. So if you have any suggestions there. Condition-based monitoring, where would you do that? And what is the difference in that and obviously reliability-centered maintenance? Any suggestions? So obviously condition-based monitoring, you're looking at a particular condition. So in the old days, and some of you may still dimly remember them, you had time-based maintenance, which is when the conveyor breaks or when the switchgear breaks, then you go and replace it. Or when you see a fault happening, you go and look at things then. Condition-based maintenance is actually about monitoring things to nail the problem before the actual bit of electrical equipment fails. So that's obviously quite important. And there's a little chart there. And reliability-centered maintenance is obviously looking at some of the critical issues. And one of obviously the drivers for this is the risk matrix. And obviously the risk matrix, you have the consequence and probability. And obviously probability times consequence is what you multiply together to get a level of risk. So that's obviously quite a high driver. And obviously you can get different levels of risk. So we obviously need to look at that from a risk-based, reliability-centered maintenance. And obviously some of the things we'll be looking at are insulation condition, DC insulation tests, partial discharge fundamentals, and obviously switchgear inspection methodologies, quite important. And I don't know, are we able to text in the box here? We're all happy texting. Obviously, people aren't texting. So obviously, switchgear is look at the health of insulation, the wear and tear of mechanical components, proper functioning of the breaker, and obviously the field reality, really important. Insulation deterioration happens, and things which obviously you need to be aware of are obviously excessive temperature. If it's hot, it's going to deteriorate quicker. Moisture, aging, accumulation of airborne dirt, and obviously vibrational shock loading. These things obviously accelerate the actual deterioration. And obviously, when you're looking at the current flowing through an insulator to actually measure it, it's got three components: the capacitive charging current, the dielectric absorption current, and the irreversible leakage current. So those are the three components. So here's a sort of chart showing you the three components, and obviously that's your test that you'll be using. And then you have a dielectric absorption curve, obviously this imperfect insulation, partial discharges occurring during the voltage. And here we have a partial discharge from a contaminating bushing with equivalent circuit there. Don't worry about that. So analysis of the recorded waveforms are important. You can detect the following: inside solid insulation, between the conductor and the solid insulation, surface tracking, arcing and sparking, and partial discharges obviously is about trend and location problem. Why would you use trend? What do they mean by that? Can anyone put in the text box what I mean by trend? Why is a trend? There's a little expression we use in electrical engineering. The trend is your friend. Isn't that clever? Do you think that's clever? What do I mean by trending partial discharge? Why do you use trending? Why not just absolute measurement? Any suggestions there? Just text in the box. Text in the box. So it's obviously a little bit of caution here. I don't know whether there's Kuma, are you seeing any thank you very much. Brilliant. Excellent. Thank you so much. Thanks, Isaiah, Utari, and Jude. Thank you very much. Yeah, so really, I mean, obviously a graphical view of what's happening is far better than text, numbers. People love graphics. Engineers love graphics. So when I say the trend is your friend, what you're doing is you look at the situation today with partial discharge, and then you look at it again in a month's time. If it's getting worse, then you say, hey, brother, there's a problem here, or sister, there's a problem here. If you say, hey, it's staying about the same, well, then there's probably not a problem. So really, at the end of the day, the trends are probably the most critical thing. It's the same with your health. If you look at your health, you don't look at the absolute value of your heart rate. You say, hey, is your cholesterol getting worse or getting better? You know, what's the deal here? You don't say the absolute value is what matters. It does give you some guidance, but at the end of the day, it's a trend. Is it getting worse? Or hey, it's getting better. So the trends are really critical, and that's why documentation of your electrical plant is absolutely critical. So is it getting worse? And obviously, where is it getting worse? Where is the problem? So that is only able to be tracked in a database, obviously not necessarily pieces of paper, but in a database, real time, hey, this is what's happening. So, and then obviously if you can use AI to correlate it with low temperature and switching events, then you really arrived. That may be a little bit ambitious, but that's quite important. So thank you so much, everyone, for contributing there. I'm just trying to read those comments there. Uh, okay, is this a recorded webinar? Yes, absolutely. You can watch it back later. Thank you very much. Sorry, we've had a comment there. Yeah, long-term view of insulation degradation rather than just a signal snapshot. So that's really, really important. Thank you very much, Mr. Kozisi, Mr. Sabanzi. Thank you very much. Absolutely right. So the trend is your friend. Isn't that a clever comment? Probably not. So you can do short-term partial discharge monitoring 1 to 2 hours to avoid any short-term variations. But obviously 1 to 2 hours just gives you that particular point, gets rid of any variations. And obviously over 1 to 3 days gives you measurement of variations over component temperature and mechanical stress. And obviously that's quite useful. And then obviously if you can do continuous monitoring of partial discharge, that is really useful because then you can automate the actual monitoring process. But you may find that will cost too much, so may not be a way to go. So the different partial discharge levels, low, moderate, elevated, critical, and obviously those are all important. And these are typical locations, which could be partial discharge, internal faults in your voltage transformers, bus bar support insulators, internal faults in the CTs, and obviously through the bushings and cable terminations. Those are all good target areas. In switchgear, obviously surface contamination, including moisture, conductor underfloating potential, arcing contacts with the circuit breaker. Loose connections are obviously also a good target. So there's different testing methods here. I'm not going to worry too much about those. Crack bushing. So obviously the tan delta is really important. And here's an example of your testing with tan delta with voltage. Really important. Contact resistance and thermal condition monitoring. You compare the phase-to-phase symmetry. So obviously if you have 150 amps in each phase, but the third phase is 80 amps, there's a bit of a problem here. So you may say, hey, there's something to look at. Measure as found versus as left. Can anyone tell me what that means? What is that gibberish I put there? As found versus as left. What does that mean in engineering jargon? Why is that important? As found versus as left. What do they mean by that? Always note the test current, lead compensation method, and joint temperature. Yeah, thanks very much. Yeah, Motoko says before the maintenance and after the before the measurement, after the measurement. So as found is when you arrive on site to do the test, you make a record. Boom. And then when you've done your testing to show that you've done something or you've fixed or done or repaired something, you show the results after you've done it. So it's as left as you leave the site. So it's quite important because your boss or the client may say, hey, brother, he or she's done nothing on site, nothing's been done at all. But if you've got a clear record, you're arrived, you're doing the right thing. And obviously it protects you. It protects you that you've done something, you haven't destroyed anything. The breaker didn't implode once you left. It actually, you tested everything, it was all fine. You measured everything. So it's quite important to do as found versus as left. Lead compensation method is obviously really important. What does lead compensation method mean? Yeah, thanks. Within adjustments, calibration limits. Thanks very much. Yeah, I've unfortunately time's tight, so I'll surge on here. But lead compensation method is when you're injecting current in and you're measuring, you don't want to have a bad measurement because the leads of your measuring thing are actually contributing to some of the voltage drop. So you want to try and give the actual measurement as accurately as possible. So that it's quite useful to tell what lead compensation that you're using. These, by the way, are all micro ohms. I'm not going to worry about these. These are just thermal gray images of an air brake disconnector. Now, if you look at this, this is the next thing, looking at air brake disconnector, and you can see the thermal gray image here. Another thing looking at thermals. What do you notice about this picture here? Can anyone tell me what they've noticed here? Now, just look at the whitish part. It's a bit difficult to see. The whitish part shows higher temperature, and the darker part is lower temperature, 9 degrees or 8 degrees. Yeah, sorry. Yeah, Linley Porto, do you mean resistance to the actual lead? Absolutely right. Thanks very much. Within adjustment calibration, thanks very much. Thanks, Mr. Linley Porto. Butu. So you'll see there the Yeah, the middle has lower temperature, absolutely right. So you'll see that there's a potential problem here. The middle one has a lower temperature. What does temperature mean when you're looking at these animals here, these um, disconnectors? What does the temperature mean? Is high temperature a good thing or a bad thing? Just put there, yeah, low current. Yeah, so the middle has lower temperature, low current. Thank you very much, Mark. Absolutely right. So yeah, so the higher heat means you've got a potential problem here. So normally you'd see probably one of them out of kilter, but here we've got two which are higher temperatures. So there's something happening here which we need to investigate further. Obviously, very useful to look at the temperature levels. Yes, typical device. I'm not promoting these devices at all, so I won't go through them very quickly. So trip coils, obviously, statistically, trip coils are responsible for most failures to operate. Obviously, which I've found happen, much to my horror, you come back onto a site after 10 years or 5 years, you think it's all been maintained, and then you find out your horror that your Yorkshire switchgear has some problems. That mentioning these names obviously ages me. Improper lubrication, or worse, the lubrication's dried out. I can never believe that oil could actually dry out. I mean, solid, shorter turns in the trip coil, the winding insulation's gone, faulty secondary winding. These are all things you've got to look out for. Seized bearings, defective latch mechanisms, corrosion, rust, and obviously incorrect adjustment of the trip latch mechanism. Someone hasn't done their job. And then obviously when you first install your circuit breaker, it should be speed time tested, and obviously it should be about 70% of rated control supply. I'm just giving you a rough figure. And the trip pulse normally about 500 milliseconds. Trip supervision constantly supervise the integrity of the circuit. So I suppose obviously the question is, does the protection actually trip the breaker under realistic control supply conditions? And obviously the other trick is to prove the full trip path from your relay output, the wiring, the trip coil, the mechanism, and the main contact separation. I suppose the question for you is, what happens when you um, what happens when your what happens with your trip coil when you've got no power, when you've got no DC battery? What happens then? And how do you deal with it? So your batteries have failed, trip coil's not energized. What happens? I must say, when I'm in industrial automation, you always have a thing called fail safe with process control stuff. In other words, no power, you protect. But what happens when you've got a breaker with a trip coil and there's no DC power for it? What happens then? Do you have fail safe then? Yeah, thanks very much. Hezbollah says, yep, absolutely. Trip circuit supervision kicks in, alarm turns on. So you should alarm that well in advance. I mean, some people have another protection further upstream where you have a breaker trip further upstream, or you have, if it's a critical one, you have a separate DC power supply. But obviously, you could also have manual operation spring discharge mechanism as well. So those are things one needs to watch out for. But you'd have an alarm well before. So it's very unlikely that's going to happen. These are some of the test equipment. Now, SF6 gas monitoring. Yeah, now I should wash my mouth out talking about SF6 gas. Because what's wrong with SF6 gas switchgear? SF6. What's the problem with SF6? Toxic, yeah, toxic and worse than that. Thanks, Hezbollah. What's worse than SF? What's worse than being toxic? It is definitely toxic. Um, Obviously, as you would guess, it's not very good for the, yeah, thanks, Hezbollah. Yeah, absolutely. Toxic and obviously environmental degradation, ozone layer damage, blah, blah, blah. So what is replacing SF6? Why do I mention it? Do we have anything? Am I completely out of date? Do we have any SF6 breakers still installed? Why do they still use them? What are they replacing them with? Methocoszizi? Yeah, the hazardous, absolutely right. And what are we replacing them with? Yeah, unfortunately, we still got lots of installed base of SF6. So even though it's toxic and it's very damaging for the environment, things don't change overnight. So you've got a huge installed um, base. So as Michael Keenan rightly points out there, we're moving towards vacuum or oil and air. So I don't know if the performance is as good as SF6, perhaps, although one could obviously debate that, but certainly we don't have a choice. We've got to protect the environment, and obviously it's toxic. So we've gone back to the more traditional um, items. But let's talk about SF6 because we've still got a lot of them on installed. So purity may degrade due to contamination by oxygen, moisture, and acidity. Hydrogen fluoride, so you've obviously got to watch out for that. So there's a bit of condition monitoring of SF6 acidity, and again, I don't want to mention all the bits of equipment, but there's quite a lot of testing that you can do. So the testing that you would be doing with SF6 obviously relates to the oxygen, fluoride, moisture, and acidity. So those are the things we'd be looking for. So maintenance procedures. Um, Most procedures are combinations of the manufacturer's requirements and obviously service bulletins and the class of the switchgear. So switchgear maintenance procedures, you can see lighting, portable lighting required to supplement fixed lighting, safe exit from substation, tools and equipment, safe working, environmental protection, protection from live LV equipment. It's obviously all important issues. Cleaning materials, unit identification, cleanliness, cleaning down of oil-filled switchgear, spray down, avoiding ingress of moisture or windborne if you're out in the desert, and solvents can also damage your installation. So be very aware of them. And obviously position indicators, oil level indicator windows. Has anyone had any issues with oil level indicators they can talk about? Chat, where they've noticed low level of oil? Can anyone give me an example where they would have seen that? No war stories on low level of oil? I can probably give a few on some remote sites which have sort of been forgotten. They sort of never operate much, and then all of a sudden you discover no one's been maintaining it for the last 10 years. Arc gaps, obviously check gaps. Earth bonding continuity. Shutters in locking devices, interlocks, obviously have a knowledge of the interlocking requirements. Other items you need to look for, ventilation. Changes around the circuit breakers may result in restricted airflow, so you need to watch out for that. Functional test, lifting devices, equipment, tools, etc. So these are all sort of things you would be looking for. Test access covers, fuses and fuse holders, fastenings, weather protection, test on completion, and obviously PCBs, which obviously we don't want to have anything to do with. And obviously, problems that you may find are keys, bolts, nuts, cotter pins, roll pins come loose. Maybe they've been very busy or there's a lot of vibration in the plant. Wood operating rods, supports, guides come loose on clamps. Look for broken welds. These are sort of things you need to look for. Contact burning. Contacts will need to be reshaped or replaced. Replacing is probably the name of the game these days. Densified wood, operating arms. So oil, you can absorb moisture and start to track across the surface. So these are all things you need to look for. And then obviously in oil switchgear, carbon or sludge to form. That's obviously a big issue. And burning or erosion. And these are all issues. And obviously bushings and gaskets, good condition. Don't try and avoid replacing gaskets. Just if you've got any doubt, friend is your friend, replace the gasket. Don't try and ignore the problems there. It's worth fixing it now. Commissioning maintenance, value comes from records. Obviously, test sheets, really important. And obviously, as I said at the beginning of this presentation, if it isn't documented, it didn't happen. So documentation, very, very critical. And you experts out there would be very familiar with bad documentation. Oil testing, obviously is a need because of oxidation and obviously deterioration of oil dielectric properties over time. And you're looking at switchgear as well as transformers. And obviously there's a little sort of suggestion here, which is not quite correct. Every 10-degree rise of maximum permitted temperature, you reduce your life by half. I don't know if that's quite correct, but it gives you a sort of indication. If the temperature is higher than it should be, you're probably reducing your transformer life. So it's quite important to watch out for things like that. And then here's some oil dielectric test. I remember many happy hours doing oil dielectric test and obviously looking at the breakdown voltage. So there's a whole thing there. And obviously the other thing is acidity tests. It's always fascinating that you can have acidity in oil. That's obviously pretty critical. So those are things, and obviously KOH, potassium hydroxide, and very important there to use that. Interfacial tension test. You have a minimum surface tension, and obviously you have a particular amount, and you need to look for interfacial tests. So these are sort of typical graphs. And obviously color is another one. Can anyone here give me examples of color they've found with testing their transformer? Sorry, Samuel. Yeah, thank you very much. I wish I could do better. Thanks, Samuel. Can I ask, has anyone had color tests with oil? And what have they noticed? Any examples? Any examples? So any war stories you've had with color in impurities, not black or brown? Any war stories? No. So basically, you often find that you get impurities in oil, and that'll give you some indicator. The change of the color doesn't say there's a problem. It just gives you a marker. Hey, you need to investigate further. Ah, here we are. Thanks, Sam. We've got brown from a 3311 kV transformer. Yeah, brown. Okay, so what 30, thanks very much. So what did you do, Sam? Did you replace the oil? Was that the ticket or did you do other tests? What other tests did you do, Sam? Thank you very much for your contribution. 3311 kV transformer, 30 years old. Yep. So that's a huge gap. Obviously, you presumably replaced the oil. Did you do any other tests? Acidity? Anyway, so that's really important, and that probably told Sam, hey, we've got a problem. Oils recycled to vacuum twice and a dielectric test flashes 60 kV. Okay, brilliant. Thanks very much, Sam. Brilliant. Excellent. Thanks. So you cleaned the oil and then you cleaned oil and then you tested. Okay, brilliant. And was checked by the manufacturer. Brilliant. You can't go wrong with that. Excellent. Thank you very much. Obviously, specific gravity is another test. Use a hygrometer for testing. Really important. Other tests are the flash point, viscosity, pour point, and resistance. So if the oil is at a low value, you know there's probably moisture or other contaminants in it. So those are all really important to look for. And here's a typical testing thing. So installation, switchgear installations, obviously rear access, work on main contacts and safety, failure to lock, um, phasing out. Fire protection in substations is another long, big issue here. What is when you're using carbon dioxide type fire extinguishing systems for your fire protection, what do you need to watch out with carbon dioxide? Can you tell me what is the most critical thing with carbon dioxide fire protection? Thanks, Sam, for your comment there. What do you need to watch out with carbon dioxide? Any suggestions? Okay, I'll jump in because obviously, yeah. So proper PPE, yeah. Thanks, Hezbollah. Yeah, so certainly be wary about carbon dioxide. You can seriously hurt yourself. It's a hazardous gas, a risk to life. Thanks, Michael. Yeah, absolutely. So carbon dioxide is not just, it puts the fire out, it actually is hazardous to you as a human being. So obviously watch out for that because it can be a problem. So obviously it's hazardous to personnel, so people often don't pick that up. They think carbon monoxide is hazardous, and that certainly is, but carbon dioxide, even though it's just a okay, thanks, Joshua. Yep. So carbon dioxide is obviously hazardous to personnel and obviously ensure alarms, delay, signage, procedures are all put out there. So that's really important. So here's in my last few slides here, I just want to say the top 8 commissioning gotchas. Gotchas means things to think about. And I'm sure many of you out there have been through this a million times, and you'll say, oh, yeah, and I've heard all this nonsense before. So obviously CT polarity ratio wrong and only discovered after nuisance trips. Yeah, I've been there. Hello, hello, happy days. So that's a big problem because you can easily connect it up incorrectly. And obviously the ratio as well, you put the wrong ratio in. Trip circuit supervision not proven end-to-end, so it doesn't work. Interlocks defeated, not reinstated. Well, I'm a process control guy, and I can promise you now, interlocks bridged out, blah, blah, blah. I've had that till I blew in the face, and you would have all come across that. So watch out for that. Secondary wiring loose or ferrules missing. Yeah, here we go. It's amazing how much bad karma there is with bad workmanship. Incorrect relay settings file, wrong revision. Yeah, here we go. Sorry. VT fuses, your voltage transformer fuses, links, test blocks left in test position. I've had that on a site in Catherine, and I can tell you now it was very embarrassing. Not from me, I didn't cause the problem. Earth bonds loose, especially doors and cable boxes. Yeah, and it's hard to believe that an earth bond would come loose, but I've seen that happen. And obviously, no baseline um, tests been done for future trending. And as I said, I know I'm sounding a bit like a stuck record here, or a bit repetitive, but your trend is your friend. sorry to keep on going, and my wife would say, for God's sake, just shut up, Steve. Your trend is your friend. The trend is your friend. So obviously trends are what matter. Cholesterol, the absolute value is not so much of a problem. It's the trend that matters. Is it going worse or better? Okay, so those are the sort of comments, the top commissioning gotchas. Sorry, I had to put those in at the end because I've seen them happen again and again and again, even with modern equipment and everything like that. So that's about it today. Thank you very much for attending this presentation. There's a lot of slides. There's 100 slides, so I'm just put them in there as extras, but just to prompt you and to think about things. In essence, if I can paraphrase two laws I always use when I'm on a site commissioning or installation, checking installation. Um, the first one, a quote I use, sorry to talk further, Kumo. The first one I always use with engineering is when there's any doubt, there's no doubt. So if you've got any doubt whether the CT polarity is right or wrong, you know for sure it's wrong, or if the ratio is wrongly recorded, you know for sure there's an error. So that's the first law. And the second rule I always use is the KISS principle. If you're doing anything, if you're testing anything, try and keep it simple. Keep it simple, stupid. Simplicity in everything you do is absolutely critical. Yeah, thanks very much. Any doubt, no doubt. Absolutely. Thank you very much, Kumar. So that's very important. And unfortunately, you're never disappointed on a site. I can't believe some people, that I suppose people are busy on site and they often don't think about things, or they're making changes too rapidly and then they don't track it, or they forget about the wrong configuration file for the breaker settings. Those are all very important. Yeah, thanks. Keep it simple, stupid. Yeah, absolutely. Any doubt, no doubt. Thanks very much for that. Really appreciate that, Kumar. You're probably a bit bored listening to me repeat that all the time. Anyway, thank you very much, one and all. Over to you, Kumar, and thank you very much for hosting me tonight. I'm sorry I spoke longer than I should have, but I
It's
had a
okay,
lot to talk
Steve.
about. Thanks so much. Thanks,
Thank you
Kumar.
so much. Thank you so much. There we have it, guys. And if you guys do have any questions, we do have some time to take some questions. If you guys would like to ask Steve any questions with regards to this particular presentation, I'll give you guys about 3 minutes to type into the chat, and then we'll give Steve like 10 minutes to answer your guys' questions if you have any. And
Oh,
I
I
did.
think I think we're probably over everything, Kumar's.
Okay, no
And
worries. So
I think if there's any questions there, thank you. Thanks. They probably would have. They've put a lot of stuff in the chat, so it's probably fine. Thank you very much, Kumar. But I just there's a comment there from Abdul Fattah Yusuf. What about unplugging manually the watchdog contact before turn on the DC because it will act like a fault because the relay will reboot? That's very clever. Uh, okay, that's with the DC. If you've got no DC power, that's clever. But basically, I was just being difficult there. I think it's very unusual. If you've got a critical circuit breaker and you want to trip it, you would probably have a separate DC power supply from a separate battery, or you would make sure you can trip upstream. The biggest problem, obviously, is that when you're tripping your breaker, you've got a 30 millisecond, say, tripping time. If you're tripping further upstream because the one's failed, you're probably looking at 100 millisecond or longer. I mean, it depends on your installation. So it's probably not as good a solution. So obviously, checking your DC power supply always is very important. And thank you, Linley. Merci beaucoup. Merci beaucoup. Merci. Thank you very much. And bonjour, Monsieur Linley Puto. Thank you very much. Thank you, Hezbollah. Thank you for your contribution, Hezbollah. You know far more than I do. I was very grateful for you sharing your knowledge And in terms of commissioning equipment, you found out that some part of the equipment not complete. What am I expected to do? Yep, that's always a challenge. That people that have done the installation haven't finished the job, and you now have to carry the can. The best is to be honest, and you tell the client, look, mate, we're talking about a variation here. I'll do the work. Can't guarantee that it'll be done on time because this part hasn't been done, but that's often a problem. It's the client to make the decision. It's not your problem, Christian. It's embarrassing when you find that out, but that's often what happens. The workmanship is always absolutely critical. Thank you very much. Thank you so much, Kumo, and I
You're
think
welcome,
that's really
Steve.
it. Thank you. Thank you.
Thank you to all our attendees for attending today's webinar. The certificate of attendance link and QR code is on the screen. And for those of you who did not receive your certificate of attendance for the last webinar that you guys attended, could you kindly resubmit your email and it will be sent to you. So on the same link that you used the last time to register, could you kindly resubmit and it will be sent to you by our marketing team as soon as possible. So thank you all once again.
Thank you so
I can
much.
put the link for you guys on the chat, and then you guys can always just copy it and go through it. Remember, there's a survey, so if you could kindly complete the survey and then submit your, there we go. I have put it in the chat, so if you could just fill out the survey and then the certificate of attendance as well as the recording and slides will be sent to you. So if you don't find it, it will be sent to you. So the certificate of attendance, it will take about 4 business days to be sent to you. However, the recording and the slides will take about 2 business days to get to you. If you don't see it in your inbox, then kindly check your spam and junk mail. That's where it should be.
It's home from home. Thank you, Kumo.
Thank you guys.
Thank you.
Take
I hope
care.
you haven't. Cheers. Have a good afternoon in Johannesburg. Thank you so much.
Will do. Thank
Cheers,
you
everyone.
guys.
Thank you very
Bye.
much, everyone. Really appreciate you joining us and your contribution. Amazingly, very grateful. Thank you so
We
much.
always appreciate
Cheers.
your attendance, guys. Thank you
Thank,
so much.
thanks so
Bye.
much. Thanks. Bye.